Today we're looking at the machine config operator. In a previous video we looked at the cluster version operator and how it manages the upgrade process. And today I thought it'd be nice to look at the machine config operator, see how it manages nodes. Its whole responsibility is managing the configuration of nodes, so its name is fairly self-explanatory. But I thought it might be nice to take a look at the various config maps and secrets and the components that make up the machine config operator and see how it goes about performing its diligent duty. So if you look at the pods in the machine config operator namespace, we have the machine config controller. We have these daemons. Now these daemons run one on each node. So we go OC get PO-O wide. We can see that they're running as a daemon set. So one on each node. So you get a daemon set. And we can see we have the server there. So when we create any kind of configuration, it's done in an ignition file. And ignition files in CoreOS are basically a declarative way of saying this is what I want my system to be configured like. And there's some documentation I'll link below from the CoreOS project on how ignition works. You can write them in a nice YAML format and then use a thing called butane to convert them into ignition files, which basically just base64 encodes like large strings. So if you had, for example, a config file, you can put it in your butane script, and then when you convert it to an ignition file, it'll be base64 encoded, and we'll see that in a second when we look at some ignition files. So ignition files in OpenShift come from the machine config. So OC get machine config. We can see we have these numerically named machine configs, and these get consolidated into a single file called the rendered file. So we have a rendered master and we have rendered worker down here. So if we take a look at our nodes, for example, so we'll use OCP worker 0 here. So OC get node OCP worker 0 YAML, and we're going to look specifically at the metadata section. We can see we have some annotations here, and we have current and desired config. So the current config is coming from this rendered worker machine config. So we do OC get machine config, paste that in, and we'll do -o YAML again. So this is the ignition file for my worker nodes, and this consolidates all of those other ignition files into one, and then applies that as the ignition file that my node is configured from. So we can see here that it manages a whole bunch of files. So let's just see if we can get a list of the files it manages. Maybe if we do q.keys. So we can see that one of the files that's managed for us is this registries.conf file. So if we take a closer look at registries.conf, we'll just pipe this to less. So here it is here. We can see that we have this base64 encoded data that forms our registries.conf file. So we take this base64 encoded data and we go echo and we decode it. We can see that we have a registries.conf file, and that contains all of the instances of my image content source policy. So we do OC get image content source policy -o YAML. You can see that these are all contained in here. I've been using two, but it doesn't really matter for the purposes of what we're talking about. So if we log into one of the nodes and we cut that file, we can expect to see the same thing that's contained in the ignition file. One of the things that comes up fairly frequently, and I see it on the OpenShift users channel on Slack, is that you might be doing an upgrade and you'll get this error mismatch state on disk. So what we'll do is we'll log into one of the nodes, in this case worker 0, because that's the ignition files we've been looking at, but for no other reason. And then we will edit the registries.conf file, and we'll just put something like this shouldn't be here in the file, and we'll just save that. So now we want to identify the daemon that's running on that node. So we'll go OC get PO-O wide. Now the one that's running on worker 0 is this one here. So we can do OC logs-f. And what we can see there is that the machine config daemon has tried to compare the registries.conf file, which is a file that it manages based on the ignition file, and it's getting something that shouldn't be there. Now, this is the error that a lot of people are reporting on the OpenShift users page, and I see it come up, in internal chats quite frequently as well, is there's some file on my system that's reporting this issue. So this will happen if you manually edit anything. Anything that's managed as part of that ignition file. You can edit anything else you want all day long, and it's not going to notice. But anything that it controls, specifically through the ignition process, it's going to notice immediately, and it's going to report this error. And this will stop it from doing basically anything else. So if we take a look at the code for machine config operator, and by the way, if I just look at the code on master, I'm not looking at the code that I'm actually running. If you want to look at the code that's actually running in your cluster, what we can do is go OC get cluster version -o YAML. So we can see here that this is the image I'm currently running. So if we do a OC ADM release info, paste that in, and then do commit URLs, this will check the image, which is obviously my own image that I've mirrored onto Quay. And it's showing the commits for everything that is running as part of this version that I'm using. So we come up to machine config operator, and we can see here that it was from this commit here. So what I can do on the Git repo, so I can do git checkout and paste in that commit. And now I'm looking at code that is the same that I'm running in my cluster. So I know that if I find a log message in the logs, I can look at the various code and it'll be on the same line number. So let's just do the logs again on that. So you can see in our log file, we're getting a log from writer.go on line 200. It's saying that the content is mismatched. So if we want to find that, we can do find.name writer.go. So we know that we're talking about the daemon, we're not talking about anything else that would be vended in. So we can look at this file here, and in that one, on line 200, we can see there that the line number matches what's being reported in my thing. So that's how you can verify the actual copy of the code from where it was built in the Git repo that you're running in your production cluster. And this will work on OpenShift, it works on OKD. What is this looking for? So that's set degraded. But what we really want to find is where it does, where it uses that, where it checks for the difference, and find out how we can fix this problem that doesn't involve manually logging in and trying to edit it and get it perfect. So this one here on line 651. Let's take a look at 651 in daemon.go. So let's do find name, and we're going to look for daemon.go. Okay, that's the file we want right there. And we're on line 651. Okay, so here we go. We're running the Preflight config drift check. So the very first thing we do is we look for a force file. So that's interesting to know. Let's keep that in mind. Because if the force file exists, then we just return at that point. We don't run the rest of the things that are here. So we get the current on disk state with this other method over here. So that's just going through the current config path. It's just returning a bunch of information. If it can't, then it's going to return an error. We don't see that error in our case, so we can keep moving on. So if validate on disk state returns an error, then we are going to write that the pre-flight config drift check has failed, and we're going to log pre-flight config drift check failed. So do we see that log in our logs? So I'll just do logs again. So we do. That's the line we were looking at from our thing. And the reason is that the content mismatched for that file. But we know that if there's a force file, it's going to skip all of that information. So if we add that force file, will that just resolve this problem for us? Well, let's take another look. force file. So this is the force file that it's checking for, and we can check the function as well. Force. Go to the definition of that. So it's just checking if this file exists. So it's using OS stat and checking to see whether the machine config daemon force file exists. Go to the definition of that, and it's what we saw in that comment. So that's probably better than checking the comment. The comment may have not been updated, but the constant is the code. So if we check for that, then we know with confidence that that's exactly what we need to set. So what we can do is we'll SSH back to that node, and we're just going to touch that file. And it looks like I'll need to sudo that. And now we can follow along with the logs again. Let's see what happens. So you can see there the latest logs is that it detected that I used SSH to log in again. Okay, so what's happening here? Skipping Preflight config drift check because the force file is present. So now what's going to happen? So it has set the post config change action to reboot, and it is requesting coordinate drain. And we can see that the node is now scheduling disabled, and it's currently draining the pods off that node. So we picked up a little bit more code here in this post-config change action reboot. So while it's doing that, it's going to drain the node, reboot it from the ignition file, and make sure that it's consistent with the ignition file. That's what's going to happen in the background. But let's go and find where this post-config change action reboot is defined within the actual code. So we'll just check and see where it exists. So it exists in the daemon go file. So let's go check that. Search for post config. So we can go to definition. So all that's doing is defining that it is something that needs to be rebooted. So does that mean that everything from ignition needs to be rebooted if we want to apply it? Well, there is a list of things that don't require a reboot with the machine config operator. This isn't one of them because anything that involves the force file, if you drop a force file and it needs to reconcile your current config with the desired config, it's going to reboot it no matter what. But there is a list of things that don't require reboots. So in our case, the node's being rebooted, but there are instances where you can change things and they won't be rebooted. And we can see that that is signified by the post-config change action none. In our case, it was post-config change action reboot. So if we read the comment for this one, it is these are the actions for a node to take after applying config changes. Machine config is applied. None means no special action needs to be taken. So this happens, for example, with SSH keys or pull secrets if they're changed. So we can see here, for example, that we set the actions to post-config change action none, and then we do some checks. So we're checking the path in the file diff set to find if the files are something that we can change without reloading, or if they're something that we will need to reload for. So we can see here the containers policy JSON. That sets the action to reload CoreOS, for example. So we can see here where it's used that we first of all define it as a post-config action none. So that's what our action is going to be. And then we're going to go through and we're going to check the paths from our diff file set. And we're going to find out whether the path is in our file's post-config change action none, which is this one here. So if it is the var lib kubelet config JSON, then we're not going to need to reboot, and we're just going to continue at that point. Else, if the path is in the file's post-config action reload CoreOS, which is this container policies JSON, then we're just going to set the actions equal to reload CoreOS, and if it's anything else, then we're going to set it to reboot and we're going to return. So what we're returning there is the actions variable. So if that actions variable comes back, so we can go to where this is implemented now. We'll just copy this and we'll do a fuzzy search for where that's implemented. So calculate post-config change action. So this is where we can see that it's going to reboot regardless of anything else if the force file is present, and that's what the comment is signifying there. So if the force file is present, then we're going to remove the force file and we're going to return the action of reboot. Otherwise, we're going to check for OS update, kernel args, a bunch of different things that also require reboots, and we're going to return reboot. Otherwise, we're going to run that function we just looked at with the diff file set, and we're going to determine whether it's an instance that either needs to reboot just cryo or whether it doesn't need to be rebooted at all. So based on that function, it's going to determine whether you need to reboot. And this is documented, and the documentation will be linked below. So we can see it's linked here. It's under Rebootless machine reboot, Rebootless updates. So we go to the Rebootless updates, and this describes everything we're just looking at. So any changes to SSH keys, the CA certificate, or the pull secret, and they don't need to be rebooted. The reload cryo action, so that's defining what would signify a reboot cryo. And basically everything else will then be a reboot. So yeah, this is all really well defined in this documentation here, but it's always helpful to know where to find it in the code if you wanted to read through it, and that's how we learn more, by actually reading the code. That's how it actually works. Documentation can be wrong, comments can be wrong, the code can never be wrong. So we've looked at the code for a bit now. Let's go back and see if our node has rebooted. So it looks like it has. So let's get the right pod for this node now. So worker 0, so it's still this one. See logs. So you can see that it has transitioned from a state of degraded into a state that is now done. So it has been updated correctly, it's in the desired state, and now we've transitioned into done. So I was actually doing a minor update of my OpenShift environment, my OKD environment yesterday, and I checked this morning and one of the nodes was actually stuck in scheduling disabled, and there was some errors in the machine config daemon logs that are similar to what we saw in the previous part of this video. So I thought I'd take this opportunity to walk through the issue I hit, have a look at some of the code related to how that works, talk through the things I did to try and troubleshoot it, and how I ultimately overcome the issue. So when I checked the machine config daemon logs, this is what I was seeing. All of these marked degraded due to unexpected on-disk state, validating against the rendered master, which is what the same message we saw yesterday when we went through, and which is the same message that we saw previously when we went through and changed the registries.conf file. But this time we're talking about the OS image URL. So the first thing I want to do is find out where this error comes from in the logs. So what we need to do is make sure we're looking at the right version of code first and foremost. So if we do oc get daemon set and machine config daemon, we just want to look for the image that it's using. So at the moment it's using the 17-7 image. So what we need to make sure is that we're looking at the code for the 17th of the 7th image. So what we can do is do our commit URLs command again. Now we want to make sure that we put in here the 17th of the 7th image. We're not using the old image, we're using the new one. So you get that from something like OC get cluster version, OYAML, and grep for desired dash A1. A1. So this is our image URL here. So this is the one we want to check the commit URLs from. So we copy that, and we can see that that's the right image there, and we're going to grep for machine config. So once we've got that, we can copy the commit hash and do git checkout on that commit hash. Now we know we're looking at the right version of code. So if we go back and find the error, we can see we had this expected target OS URL, OS image URL. That's the string for the error we're looking for. So if we just do a fuzzy search for that, we can see it appears in one file, which is the daemon.go file again, the same one we looked at previously. So we can see what happens here is it checks for the current config spec OS image URL, and that goes through and checks against what is defined as the daemon's booted OS image URL. So it checks for the booted image URL against what is defined in the config, and if there's a difference, then we return that error. So what we know from the error and the fact that it just kept looping was that we're kind of stuck somewhere. We don't know why we're stuck, but we know we're stuck. So the next step for me was I would just drop that force file and just see whether that actually helps us get past this, because I know that will skip the validate on disk state implementation. I don't know there's some other code in there that will then be executed because we've managed to skip this. So I just wanted to try that first. That's the least invasive solution I could think of. So I tried that, it rebooted my node, I checked the uptime, it was only a couple of minutes, so I knew that it had been rebooted and I was still getting the same error. So the next thing I wanted to try was, I know that for this update to occur, it uses rpm-ostree. So the OS image URL itself, we can find in the release payload. So if we download our release payload, which I've already done, but you would use this command, so ocadm release extract, paste in that same image URL that we just looked at the commit hashes from, and we're going to unpack it in the release image directory. So if we go into the release image directory and we do a search here for OS image URL, we can see we have this config map file. Now in this config map file, we can see it has an OS image URL, and that points to what we would expect to be the image URL after the update has proceeded. So we're just going to double check this in the cluster as it is at the moment. config map. So we can see there that the config map has been updated in the cluster, and we kind of know that because the current config has been updated, but we're just verifying that that part of it has actually worked. And it has. So the next thing I thought of doing is, well, I know that to get to this, we need to rebase on it. So what this is an OCI image, so a container image that has all the rpm-ostree commit hashes and inventory pushed into a container hosted on a registry. So you can write a container file, put a bunch of rpm-ostree commands in there to install things that you want to use for your rpm-ostree image, push that up to a container registry, and then you can rebase on top of that from anything. So I'm using Silverblue on my work laptop, for example. Obviously this is a MacBook, but my work laptop is using Silverblue. And what I've done there is I've built a container image that has the things installed that I like NeoVim, Go, Rust, the other things that I wanted installed actually on the host system and didn't want to have to mess with Flatpaks for. So that's a pretty cool process, and I'll leave some documentation and a couple of videos about how that process works down below. But what we need to know for now is that somewhere along the lines, we should have done a rebase on this image, and we haven't. So if we go back to the machine config operator, what we want to look for is just rebase. And we want to look for something that looks like a rebase command, and I think it's this one. So what we would run is rpm-ostree rebase experimental ostree unverified registry, and then our image URL. So the next thing I wanted to try was I want to do that manually, and I want to reboot the node and then just see if it works. So what we did was log into the node. So we can see that what I did there was I run sudo rpm-ostree rebase experimental ostree unverified registry, and then I used the image that I got from the config map to rebase this system on, and then I just rebooted it. And after I rebooted it, it all came up, it was all happy. The node moved into the done state, it matched the current config, it was uncordoned, and the update has now started proceeding. And I probably should have recorded that, but if we do get nodes now, we can see that it's moved on. So this was the node that was failing. That was the node that was failing, the control plane 1, and now it's doing control plane 2. So we're just going to double check control plane 2 and make sure it's not in the same situation. And if we are, we'll go through that process again, but we'll double check to see what's happening over here. So I want to check control plane 2. This is it here. So it looks like that node is actually being rebooted at the moment, so we can't connect to that image. We'll just wait for it to come back up. Okay, so our node's ready there again now, so let's try and follow along with the logs here. Okay, so we can see this one has booted into the correct OS image URL in this case, so this one isn't having the same problem that we just had. So that's good. But I don't really understand how we ended up in that situation to begin with. So there's probably some opportunities to improve the logic within the machine config daemon with how it handles those rpm-ostree rebases, and if it fails, we can probably implement some kind of retry logic there to fix that. The main thing is that we were able to apply some of the knowledge that we looked at in the previous part of this video to troubleshooting this issue, and some of the knowledge of knowing like where to find the code, the log messages, and just being able to read through and understand what's actually supposed to happen enabled us to move forward. Now, obviously, I would never recommend that you do this in a production OpenShift environment. If you hit this in a production environment, you raise a support case and chat with the support folks, and they'll walk you through how to recover from this situation. But definitely in a lab environment like this is, it's all about learning. It's all about improving the knowledge we have of the platform so that we can feel more confident with it in other situations. In that context, it's definitely worth reading through the code and trying to understand it for yourself to get an idea of what should have happened so that you can understand what hasn't happened, and then you can try and do it yourself just to see whether that fixes the problem. And in my case, it did. And now that enables me to start looking backwards from that point to see at what point, maybe we missed something and we didn't retry it, so we ended up in this state. And that gives me the opportunity to maybe contribute something back to the machine config operator and improve that logic moving forward. So in summary, the machine config operator for OpenShift manages the configuration of your machines, and that includes any of the configuration files that are specified within the ignition file. So we looked at ignition files and what's defined there, and the consequences of changing something outside of ignition. If you create a new machine config, it will correlate that into a new rendered version of the ignition file, and it'll reboot your node from that. In some circumstances, there are some things you can change that don't require reboots, but in most circumstances, it does require a reboot. So we also looked at how to get the exact version of code running in your cluster by looking for the commit hash from your release, and that enables you to be confident, and when you see a log message, you're going to find it in the code at that same line that the log message is reporting it's at. So you can be confident the logic around that is exactly what's running in your cluster. You don't need to be making assumptions and guessing. Finally, in this part, the second part of the video, I've showed how the OS image URL is updated as part of the release payload. It's in a config map. And then our machine config daemon uses that OS image URL to rebase our nodes on top of. And that OS image URL is an rpm-ostree OCI container image that's being pushed into Quay or into your mirror registry, and we're rebasing on top of that, which is a pretty cool process that rpm-ostree has the capability to do. So I hope that helps to improve your confidence with machine config operator. Definitely go and play with it, try and read through that code and understand for yourself what's happening, and then have some guesses at how you can fix your problems and how you can change things in your environment. Try and rebase onto an image that you're not currently running and see what happens. These are the type of things that when you explore, you build confidence in your own ability to solve the problems, and you build confidence in your own understanding of the platform in general. So I hope you find that useful. If there's anything that you wanted to know specifically about machine config operator, I'm happy to dig into that and make a second part to this video. And as always, if you have any questions, hit me up below, and I'll see you in the next video.